Okay, so let's look at the factor theorem. If we're given a function, let's say this function here of 2x cubed plus x squared plus 5x minus 8. Okay, if I were to say to you, to give you and say to you that x minus 1 is a factor of this function, then if I were to divide this function by x minus 1 using our knowledge of division of polynomials, or synthetic division as the Americans like to call it, if I were to divide this by x minus 1, I wouldn't get any sort of remainder. Let's do that. I'm going to use division of polynomials. There is another method by inspection, and we can go over that another time. But if we divide this through by x minus 1, x into 2x cubed goes to x squared. 2x squared times x is 2x cubed. 2x squared times minus 1 is minus 2x squared. If I take that away, I get 2x cubed minus 2x cubed, which is 0. I get x squared minus 2x squared, which would make it 3x squared. Okay, let's do it again. Remember, this is like a dance. So let's start the steps again. X into 3x squared goes 3x. X times 3x is 3x squared, as we said. 3x times minus 1 is minus 3x. Let's take that away, and we get 5x minus 3x with 8x. X into 8x goes plus 8. Plus 8 times x is 8x. Plus 8 times minus 1 is minus 8. If I take that away, I end up with minus 8 minus minus 8, which is 0. So I could rewrite this function of f of x of 2x cubed plus x squared plus 5x minus 8. I could rewrite this as x minus 1 multiplied by 2x squared plus 3x plus 8. Let's think about that for a second. Maybe take some numbers here. Let's say 5 into 35. Well, that gives us 7. So in other words, 5 multiplied by 7 equals 35. So I've specialized in order to just check this idea. I put a particular value in just to reassure myself that this idea works. So this multiplied by this will always equal this. Now, in this here, let's take that for a second. If I was to substitute in x equals 1, so in other words, f of 1, I would get 1 minus 1 into 2 times 1 squared plus 3 times 1 plus 8. And actually, I don't really even need to work out what this is, because I know that 1 minus 1 is 0, and 0 multiplied by anything, I mean, it happens to be 13, but 0 multiplied by anything equals 0. So I know that equals 0. So let's think about this for a second. If I substitute in the value of 1, which is connected to here, is the negative value of this. If I substitute in 1, I get 0. I know this is a factor. So generally, what I can write is, if f of a equals 0, in this case it was 1, then x minus a, here x minus 1, is a factor of f of x. It's almost like doing this polynomial division in reverse. We're saying, we're using the fact that we got 0 here at the end, and we're saying that if we substitute in the value of 1, this 1 here, this a, then x minus a is a factor of f of x. Let's look at an example, and we'll come back to this. If I was to factorize, if the question was to factorize f of x equals x cubed plus 6x squared plus 11x plus 6. We can use this idea here. And we can say that, well, if we can substitute in something, I don't know, f of 1, for example, and it equals 0, then we know that x minus 1 is a factor, and we can divide through. Let's see. F of 1 is 1 cubed plus 6 times 1 squared plus 11 times 1 plus 6. That's 1 plus 6 plus 11 plus 6. Now that is not 0. And my feeling here is whatever positive number we put in here, I think it's just going to probably get bigger and bigger. So we could try a negative number. If we tried minus 1, we would get minus 1 cubed. Now notice I'm using brackets here. I didn't use brackets before because it was positive. Here, brackets, whenever I see negatives, I use brackets. It doesn't always stop the mistakes, but it minimizes those silly mistakes. So 6 times minus 1 squared plus 11 times minus 1 plus 6. Minus 1 cubed is minus 1. Okay, minus 1 times minus 1 times minus 1 again, minus 1. Minus 1 squared here will give us 1. Multiplied by 6 will give us 6. Minus 1 times 11 will give us minus 11. And then we want to plus 6. This equals minus 1 minus 11, which would be minus 12, plus 6, which is plus 12. And that then does equal 0. So what does that tell me? It tells me that x, remember it's the negative value of this, x plus 1 is a factor of f of x above. And that's useful because now I can divide through by x plus 1. Let's do that. Again, I'm going to use division of polynomials here. Let's divide through by x plus 1. So x into x cubed will give us x squared. So remember, x cubed divided by x will equal x squared. X times x squared is x cubed. X squared times 1 is plus x squared. If we take that away, we get 6x squared, take away x squared, which is 5x squared. Let's do it again. X into 5x squared. Again, if we get confused with this at all, we can just do this and we end up with 5x. So 5x is there. X times 5x is 5x squared. We've got that already. 1 times 5x is plus 5x. Let's take that away and we end up with 11x, take away 5x, which is 6x. X into 6x, or 6x divided by x will equal 6 plus 6. 6 times x is 6x. 6 times 1 is plus 6. If I take that away, I get 0, which is to be expected. So I know that f of x now could be written as x plus 1 into x squared plus 5x plus 6. Now, just before we go on, let's just remember that we have a quadratic here, and a quadratic we can solve. We've got various ways to solve it. If it's not solvable, we can deal with that as well. I'm looking at this and thinking I'm seeing a 5, they're both positive. I'm seeing a 6. I know my factors of 6 and 1. I can make a 5. I think I can factorize this. So I'm going to have a go at that. X squared plus 5x plus 6. My factors of 6, as I said, are 6 and 1. And if I have plus 6 and I take away 1, I end up with 5x. So I could factorize this as x plus 6 and x minus 1. Let's just check that. X squared plus 6x minus x. Something's wrong here. Can you see? We need two roots that are positive. So maybe it's not this. What are our other factors? Well, we've also got 2 plus 2 and plus 3. So this could also be rewritten as, this is wrong, we could also be rewritten as x plus 2, x plus 3. Let's see if that works. X squared plus 2x plus 3x makes 5x, and plus 2 plus 3 this time makes a positive 6. So this is the correct factor if we factorize this expression here. So writing this out then, we would get in full x cubed, well, this is f of x, equals x cubed plus 6x squared plus 11x plus 6. That was my original problem expression. X plus 1, x plus 2, and x plus 3. And you know, we could check something here. We could put in f of minus 2. We could put in f of minus 3. And we would expect, if we put in minus 2 or minus 3 from the factor theorem, that this would equal to 0. Now I'll leave you to do that.